Hi, welcome to the Advanced Networking Demo Series. In this video, we will be talking about multi-cloud private DNS. My name is Ishira, and I'm a network specialist customer engineer based out of Sunnyvale. I'm super excited to cover this topic with you, so if you're ready, then let's get started. As customers expand their cloud footprint beyond a single cloud provider, the need to establish a private network infrastructure between the various cloud providers becomes even more important. Now, one of the crucial aspects of the private network infrastructure is the need for private DNS endpoint resolution between the cloud providers. And one of the reasons for this is that the applications hosted on one cloud provider will need to access the resources hosted on the other cloud provider and vice versa. So in this demo, we'll take a common multi-cloud private DNS scenario, walk through some sample requirements, and then present a solution demo. Now let's look at a common customer scenario. The customer has applications already hosted on both clouds and is in the midst of a multi-cloud expansion. The application hosted in AWS needs private DNS resolution for Google Cloud hosted resources and vice versa. They already have a high availability VPN tunnel established between both the cloud providers, and they would like us to use this connectivity option as well. Now let's walk through the customer requirements. The number one being a private and secure DNS resolution between both clouds, and along with that, ensuring high availability. Also, one of the requirements are around using both clouds' managed offerings in the solution as much as possible, as that would ensure less operational toil. And lastly, they would like us to come up with a cost-effective solution, as cost is something that is a requirement for their business. So let's look at the DNS and network routing flow for inbound forwarding of the DNS queries. That is from the AWS EC2 instances to the Spoke 1 and Spoke 2 domain names. So the EC2 instances located in AWS in both the Spoke VPCs send the query to their local DNS resolver, and per the Route 53 forwarding rules, they get forwarded to the Route 53 outbound endpoint associated in the hub VPC. Now, the Route 53 outbound endpoint then forwards the DNS query to Cloud DNS, and Cloud DNS receives the queries via DNS inbound server policies and forwards these queries to the respective spoke VPCs, as it has a DNS peering established between itself and the individual spoke VPCs. Now, from a network routing standpoint, the transit gateway ENI that is present in both the spoke VPCs has an attachment to the AWS transit gateway, and the AWS transit gateway already has routes in its route table to forward traffic to the cloud router on the Google Cloud via AWS site-to-site VPN connection. So that's how the routing of the requests work. Now let's look at the DNS and network routing flow for the outbound forwarding side of things. So the Google Cloud VMs essentially send the DNS queries to the Spoke 1 and Spoke 2 multi-dns.aws.com. So from a DNS standpoint, the query from each of the Spoke VPCs is sent to the Cloud DNS local resolver, and as you can see, and via DNS peering, it gets routed to the DNS forwarding zone in the hub VPC. The DNS forwarding zone also sends the DNS queries to the inbound endpoint that is associated with the hub VPC. Now, the Route 53 resolver inbound endpoint uses the VPC plus 2 resolver, and the private hosted zone that's associated with the hub VPC already has records for the spoke1.multidns.aws.com and spoke2.multidns.aws.com, and that's how the query resolution works. Now, when it comes to routing, the cloud router actually advertises custom routes, that is the /19 route to the AWS transit gateway, And the AWS Transit Gateway already has the route for the /19 dynamically propagated in its route table. And so does all the individual TGW subnets in the spoke VPCs have that route as well. So that essentially from a routing standpoint, the AWS Transit Gateway receives the route and then it forwards it to the individual spoke VPCs through the ENI attachment. So now let's look at the network infrastructure. This diagram represents that, and I've already gone ahead and created this on my end in the interest of time. Just walking through what I have set up, we have three projects on Google Cloud. One is the Hub project and two Spoke projects. Each of these projects have VPCs in them. I've already spun up GCE instances in each of the Spoke VPCs, and the resources in all of the projects are launched in the US East 4 region, and that's one of the requirements that are called out in our best practices doc. Now, on the AWS side, there are three VPCs as well, one Hub VPC and two Spoke VPCs. Both the Spoke VPCs have EC2 instances launched in them, uh, and all of the instances are running in the US East 1 region, or rather, all of the resources as well. Now, an HA site-to-site VPN connection already exists between Google Cloud and AWS, such that there are 4 tunnels on the Google side and 2 VPN connections terminating on AWS Transit Gateway on the AWS side. And each VPN connection has 2 tunnels each. So that's uh, a brief overview. So now before starting the demo, I just want to call out that this demo will, for the most part, focus on setting up the DNS configuration on the Google Cloud side. And thus, in the interest of time, I've already created the following components or resources in the AWS Route 53 console. So I've gone ahead and created a private hosted zone in AWS Route 53 with the record name multidns.aws.com, and it has each of the Spoke VPC records in them, as you can see. I also went ahead and created an inbound endpoint. This is the resolver ID. And while creating the endpoint, I also attached a security group that has rules that allow incoming traffic from the Google Cloud DNS IP addresses via the TCP UDP port 53. And it also has two inbound endpoint IPs for availability. And I would suggest keeping a note of it for future configuration. Also, the subnet attached to these IPs have routes pointing to the Google DNS IP, that is the 35.199.192.0/19, pointing to Transit Gateway, and we'll see how. So this is the subnet, this is the route table. I filtered it with the Hub VPC. And as you can see, voila, the /19 is attached to Transit Gateway. We'll move on to GCP side of configuration, and just a word of caution, to perform this demo on Google Cloud, you must enable the Cloud DNS API and grant the necessary DNS permissions or IAM roles like DNS admin and DNS peer. So let's go ahead and create a zone in Spoke Project 1. Under the Zones tab, we'll hit Create Zone. And once we hit Create Zone, we will select Private as the zone type. Zone name would be spoke1-multi-GCP, multi1.gcp.com as the DNS name. Keep the default as private, network spoke1, and hit Create. And we can see the NS and SOE records have already been created. And we'll now create the A record of Spoke 1 and point it to the EC2 instance. And then we'll also go ahead and create the Spoke project 2, and I'll be right back. And there you can see spoke2.multi2.gcp.com pointing to the EC2 instance in Spoke 2. Now we look at the inbound server policies that I already went ahead and created while I was creating the VPC in the Hub project. It is named as AWS Inbound. Inbound query forwarding is turned on in use by the Hub project, and this is an IP that you need to keep note of, as we'll be using it in future configurations during AWS's outbound endpoint creation. These are nothing but regional internal IPs that Google allocates to the inbound server policies. So just something to keep note of. So now we'll proceed with creating DNS peering for both the directions. Given its unidirection, we would need to create two DNS peering zones in Hub and then one each in the Spoke project. So in the Hub project, you hit create zone, select zone type private, put a whichever zone name that you like. Now in the DNS name, we would add the one that's assigned to the private hosted zone of the Spoke One project, which in our case is multi1.gcp.com. And then in the options, you'll keep the options as DNS peering. You'll select the network as Hub. For the peer project, you'll select Spoke Project 1, Peer Network Spoke 1, and there you go. This is the Spoke 1 peering from the Hub VPC. We'll create a similar one for Spoke 2, originating from Hub. I will go ahead and create this peering along with the Spoke peerings and get back. Yeah, so there you go. This is the Hub Spoke 2 peering. The DNS name is multi2.gcp.com. Peer network is Spoke 2. And similarly, in the Spoke project 2, we'll create a peering to to the Hub project, where the DNS name is multidns.aws.com, which is the private hosted zone in AWS. And the network is Spoke 2. Similarly, we'll create one for Spoke 1. Now let's create a forwarding zone in our Hub project. Zone type would be private. You can put forwarding as your zone name, multidns.aws.com, because we are forwarding queries to another server. And the network would be Hub. Now, looking at the IP address, we'll select the two IP addresses for the inbound endpoints that I asked you to save earlier. So you'll add that. You'll select private forwarding for both the IPs and hit create. This creates a forwarding zone in your Hub project to forward DNS queries to AWS. Now we will modify the cloud router routes as they have a default advertisement enabled on it. We will basically change it to custom route propagation. And to do that, we'll go to the cloud routers under hybrid connectivity console, click on edit, and then we will select create custom routes, select advertise all subnets, um, and then create a new custom route with a custom IP range to 35.199.192.0/19, which is a cloud DNS range, and then add a description, hit save, and then we'll go to the AWS side of the console and go all the way down to transit gateway route tables, which you can see right there. And we'll hit refresh because the view hasn't been updated. And there we see the /19 route being propagated from Google Cloud. Now we'll move on to creating an outbound endpoint and we'll see how to do that. I already created it actually, and in the interest of time, so I'll just review of the configuration. So it's basically it has a security group. It is attached to the host, that is the Hub VPC. We also we'll have to assign two IPs to the outbound endpoint for high availability in each of the AZs. And then we'll create two outbound rules for this outbound endpoint. The rule type would be forward. The domain name would be multi1.gcp.com, which is the Spoke One side of the GCP, and attach all the three VPCs for correct routing of the request. And in the IPs, what we'll do is we'll add the inbound server policy IP that we got in GCP, and then we'll start testing. Basically, we'll create another endpoint, another rule for spoke to as well, which I already did. Now let's run a dig from the AWS EC2 spoke one instance to, or we can do an NS lookup to the spoke one DNS domain. That works. We'll also do that for spoke 2 and that works as well. Now let's run the same commands from the spoke 2 EC2 instance and they both seem to be working. That's awesome. Great. So basically our outbound our forwarding from AWS to GCP is working, or you can call it inbound forwarding to GCP. You can name it any which way. Now let's see from the GCP side of things, does the forwarding work to AWS? Seems like the spoke to VPC has it working. Just running both those commands. And looks like we have successful resolution. To get more information on Cloud DNS best practices, please read the documentation on the slide deck and check out the links in the description. Have a good day.